Let's remember our future value of annuity formula. Cash flow, each period, periodic cash flow, times 1 plus I raised to n minus 1 divided by I. Right, so let's plug the numbers in. What's our periodic cash flow? It's $6,000. All of this is annual, so we don't have M anywhere here. So times 1 plus I is 0.08 raised to, so now that's one thing to be careful about. So another thing to be careful about when we are dealing with deferred annuities is what exactly is this N? Right? Sometimes I see mistakes, people make mistakes. They put like 7 here because that's the last cash flow. No, in annuity formulas, our basic annuity formulas, N refers to the number of cash flows, how many cash flows there are, right? So here we have 4 cash flows of 6,000. So N is going to be 4 minus 1 divided by I, okay? And this, if you crunch the numbers using your calculator, right? So first calculate that, 1.08 raised to 4 minus 1, that divide that by 0.08, and now multiply that by 6,000. So there are 4 cash flows of 6,000. So this number is going to be a little bit greater than 4 because we are earning interest, right? So we're going to end up with not 4 times 6,000, 24,000, but something a little bit higher thanks to compound interest. And if you crunch the numbers, what we're going to get is 27,036.67 if you round to the nearest cent. And where would that be? That would be here. That's how much we would have. So if we have 6,000 each year starting in year 4, earning 8%, and we are putting another 6,000 also earning 8%, another 6,000 earning 8%, by the end, when we put the last 6,000, we're going to have exactly this much in the account. Okay? So now let's add a complication to this. Right? And you will encounter this. Say, all right, this is how much we deposit. These are the cash flows. Say 20 years from today, how much would you have in the account? So this is how much there is by the end of year 7. And now we are not making any deposits. What happens? Right? So the way we're going to think about this is going to be this. We can think of this as now single cash flow, right? Earning interest 8%, or earning, in stock market, average return in the stock market for the remaining 13 years, right? So this becomes a single cash flow problem where this amount is going to earn 8% for 13 years. So how would we approach this? We would say future value, let's put this 20. Future value as of year 20 is going to be now this is our new PV, right? We are shifting perspective. We have this much. So we're going to use the FV equals PV times 1 plus I raised to n formula, right? So PV times 1 plus I raised to n, but our perspective changed. So this is now our present value. This is how much we have. There are no cash flows anymore. This is going to earn 8%. So now we've got to be careful about this. What is that n? It's not the same n. We shifted perspective. Right? Here with annuity formula, n was the number of 6,000s. And now here, n is for how many years will this amount, starting amount, earn 8% return. And that is from 7 to 20, that's 13 years. So 13 years of compound 8% return, 73,000, and let's round this to the nearest whole number, 530. So we're going to end up with something like 73,530 by the end of year 20.